take a very good look at this question. Now we are dealing with weight in a lift, and you can go and watch my video on the previous lesson on weight in a lift. When the lift is moving up or down or moving with acceleration that is equal to g. Now, in the diagram, this is the diagram. A painter is in a crate. The crate which hangs alongside the building. When the painter who weighs 1,000 Newton. Now, weight of the painter, let's write it here. Weight of the painter is what? 1,000 Newton. Pulls on the rope, the force he exerts on the floor is what? Is 450 Newton. So let's call that our normal reaction. 450 Newton. So if the crate weighs 250 Newton, weight of the crate, this will be a normal reaction because if I exert a force of 450 Newton on a table, the reaction that the table will react back to me will also be 450 Newton. So since it exert a force on the floor in 450 Newton, the normal reaction on the floor is what? 450 Newton. So the weight of the crate is also what? 250 what Newton. Find the acceleration. Now we have to take acceleration to be upward. That's not even the main deal now. Now we have two scenarios here. Please take note of that. We have two scenes. The first scene you need to take note is what? The man, the rope, and the floor. Let me see if there is space there. So the first scene, first scenario is what? The man, the rope, and what? The floor. Now the second scenario, the second scene is the crate itself. The crate, you know we are given two different weights. The weight of the man and the weight of the crate. So the first thing deals with the man. So what are the other forces attached to the man? Is the rope because the man is holding on to the rope. And the floor because the man is standing on the floor. Though the floor is the crate itself, this is the crate. Are we together? Now the second weight given to us is the weight of the crate. What are the things that are attached to the crate? This rope, because the crate is also tied to the rope. Are we together? The crate, the rope, and what? The normal reaction. Why? Because the man is standing on the crate. There's a reaction between the man, the foot of the man, and the surface of the crate. The normal reaction. So what we need to take note now, let's take note of the first thing. So for the first thing, we need the net force, the resultant force. The resultant force is the summation of the total force acting on the body, whether some parts are upward or downward. So in that case, we'll be adding those signs, whether we are going to subtract at the end of the day. But don't forget, it's the summation of the total force acting on the body. Now, look at the first thing, the man, the rope, and the floor. Now, the man, the weight of the man is acting where? Weight is always downward. Weight is always downward. So don't forget, net force, our net force equals to upward force minus downward force. Our net force is upward force minus downward force. Yeah. So let's see our upward force. What are the things acting upward? What are the things acting downward? Now look at the man. The weight of the man is where? Downward. The tension in the rope is upward. Because if my weight is down and I'm holding the rope, there's a tendency of the rope trying to pull me up. So the tension in the rope is upward. Now also the normal reaction. If this man exerts a force of 450 Newton on this floor, the reaction of the floor to the man is also what? Upward. The man will be reacting to the foot of the man in the upward direction. So this 450 Newton is also going to be acting upward. Now our upward force our upward force is tension in the rope and this normal reaction, the reaction which is upward. Relating to this man, the reaction is upward because the man is standing on the floor. So normal reaction is opposing the man. It must oppose the weight of the man. So the reaction is upward. So our upward force now is what? Tension plus normal reaction. What's our normal reaction? 450. Minus what's our downward force? The weight of the man, which is what? 1,000 Newton. Minus 1,000. And don't forget, net force is what? Mass times acceleration. Are we together? So it's going to give us and M1A. Do we get that? This M1 is the weight of the man because it's the man here that we are talking about in the first scene. It's the mass of the man rather. Since the weight of the man is 1000 Newton, how do we get the mass of the man? Don't forget weight equals to mg. And if our weight is 1000 and g is 9.8, here we have 9.8 m. So m is going to give us 1000 divided by 9.8. So if we make m the center of the formula. No, I'm almost done. So divide both sides by 9.8. 1000 divided by 9.8. So the mass is what? This mass here is 102 grams or kg rather. So here we have 102A. Now we are done with the first scene. Now for the second scene is about the crate because we have two weights in question: the weight of the man and the weight of the crate. So dealing with the man alone, because there is a rope attached to the man, there is a floor at which the man is standing on. So this is the first scene. Now dealing with the crate, there is a rope attached to the crate, there is a reaction on the crate. This is the second scene. Now for the second scene, now this is our first equation 1. Now for the second scene, let's see, net force is upward force minus downward force. Now let's see how many forces are acting upward. Now relating to the crate, the weight of the crate is where? Where is the weight of the crate? 250 Newton. The weight is always downward. The weight of the crate is always downward. Don't forget. The weight of the crate is downward. So 250 Newton downward. Now what's up? This tension is upward. Don't forget. And what's the tension? See? Which is what? Upward, right? T is upward. Minus what of the rope? The tension in the rope is upward. The weight of the crate is downward. What of the normal reaction? Now, if this man exerts, listen now, when we were considering the man, the reaction on the man is upward. Do we get? Now, if this is a table, if I'm standing on a table, this is my hand on this calculator. The reaction on my hand, as regarded to my hand, is upward. But the reaction on this calculator is downward. The reaction on that crate is downward. But the crate is reacting on the man upward. That's why for the man, our normal reaction on the man is upward. But for the crate, the man is the one standing on the crate, is the one reacting on the crate. The weight of the man is on the crate. So the reaction of that man to the crate is downward. It's the reaction of the crate to the man that is upward. But our normal reaction for this second scene now is downward. Because it's the man that is reacting on the crate. Downward direction. Since the man exerts a force of 450 Newton. So this 450 Newton is downward. In the case of the crate. But in the case of the man is upward. So our downward force is 450 plus 250. So this one will be upward minus downward equals to what? M2A. Net force is mass less acceleration. And what's the mass that we are referring to here? That's the mass of the crate, right? And since the crate is 250 Newton, how do we get the mass of the crate? Weight equals to mg. 250 equals to m times 9.8. So 250 divided by 9.8 to get our m. 250 divided by 9.8. So that's 25.5. So here we have what? 25.5A. We have 25.5A here. So this is equation 2. Let's write everything together. Equation 1 is T plus 450 minus 1000 equals to 1028. Is that clear? Now, this T minus 450 plus 250, that's what? That's 700. So equation 1 returns to T minus 700 equals to 25.5. Equation 2 returns to T 450 minus 1000, that's 550. So equation 2 returns to what? Plus 550 equals to 128. Equation 1 rather returns to this. So this one returns to this. Just add this, you have 700. Subtract this, you have this. Are we together? So now what are we going to do now? This is like a simultaneous equation. So we have to eliminate T. How do we eliminate this? By subtraction. We can't add this time. As long there is a minus here, we can add, do addition to eliminate it. But since they are the same, we can subtract. Now, if you subtract the two equations, see we cancel. So here you have minus 700 minus 550. That's minus 1,250. Here you have 25.5 minus 102. 25.5 minus 102. That gives us minus 76.5. Minus we can A rather. A. So minus we cancel minus. At the end of the day, you have your what? Your A to give you 1,250 divided by what? 76.5. So 1,250 divided by 76.5. So your acceleration is 1,250 divided by 76.5. So this gives us what? 16.34 meter per second square. So that's the acceleration. Let's check if I have not made any mistake. Let's check. Let's check something very well. It's like we made a mistake. Let's check something very well. It's like we made a mistake. Just listen. Now let's check. The first thing, the man. Our upward force is the tension. The weight of the man is downward. The reaction on the man is upward. I've explained all that earlier. So our upward force is the tension minus downward force. The weight of the man is 1,000 plus we have two downward forces. Sorry. We only have one downward force, the weight of the man. Our upward force is the tension and the reaction on the man. Since the man is standing, this plate is reacting in the upward direction. So tension plus the reaction on the man is what? 450 Newton minus the downward force. If I'm reacting a force of 10 Newton on a table, the table is reacting the same force on me, but in the opposite direction. So if I exert a force of 450 Newton on the table is exerting the same force on me in the opposite direction. So since the man exerts a force of 450 Newton on the crate, are we together? So the crate reacts with the same amount. So since the reaction is upward, tension is also upward. So upward force we have to minus downward force equals to mass times acceleration. The mass of the man is the weight of the man divided by gravity, which we got 102.8 mass earlier. Now equation 2, our upward force is tension minus we only have one upward force. Our downward force is the weight of the crate, which is 250 plus we also have another downward force, the reaction on the crate. You know the crate reacts on the man upward, so the man reacts on the crate downward 450. Because we get 25.5 earlier to be our mass. Like the mass of the crate, the weight of the crate divided by gravity will give you mass of the crate. Net force is mass times acceleration. Our net force is upward minus downward, upward minus downward. So this one gives us this plus this, we have 700. So this one 450 minus 1,000. That is 450 minus 1,000. That's minus 550. Sorry. So here earlier we should get t minus 550. So this one should be t minus what? 700. Yeah, 700. That's how you should. I think I wrote plus here earlier. It's a mistake because of that plus that. So here now let's subtract. This will cancel. This will be minus 550 minus 700. If you subtract t minus t go. Minus 550 minus 700. That will be plus 150. So we have 150 equals to 102a minus 25.5a. 102a minus 25.5a. That gives us 76.5. So here we have 76.5a. So a will give us 150 divided by 76.5. 150 divided by. Yeah, so this is the correct answer. Our a is 1.96 meter per second square. What I explained earlier, maybe you should reuse the video and go and play it very well. The only mistake in that calculation is that I put plus here by mistake because the thing was like this. Plus, I think we have something like 450 minus t plus 450 minus 1,000. So because of this plus here, 450 minus 1,000 is minus 550. So instead of writing t minus 550, I wrote t plus 550. That's what made the initial one to be mistake. So take note of that. So that's the answer. See you in the next video. Don't forget to like and subscribe. Thanks.